Hello and welcome again to Chem in 3. It was about 1 year ago that we made the first episode of Chem in 3. And today, we're about to start episode 33 of Chem in 3. We take a more in-depth look of what was covered in lesson 2 of Chem in 3. Orbital hybridization, by looking at a past exam question and how to go about analyzing it to get to the solution. Let's move inside and take a closer look. Right. So today we have Debaria, Momin, Vyom and Kewal in our HL chemistry class, and we are ready to take a look at some questions involving hybridization. With this structure here, we have to identify what type of hybridization you have at X, which is here, Y here, and Z here. And I have 4 choices. So I'm going to call first on Kewal to tell us what is the hybridization at this point here with X, and what is his reasoning.
So let's take a small cross section of this part here. And so we can see that we have a joint here, which means you have a carbon there, and one more joint here. So, and since it's benzene, it's something like that. So now you can, and then again, the important thing the mistake you'd make here is that you think it's, you'd forget this hydrogen bond. And so with 1, 2, 3 bonds, it would be sp2 hybridization, because the total would be.
What is going to be the shape of this? If this is at the center and you consider this bond, this bond, this bond, how would you identify the shape as?
Trigonal plane.
Well, these are 2 signs. The fact that you have these 3 domains is what they are called, 3 domains, which then leads you to this shape and then to this hybridization. So that's sp2. So now we're ready to move to Y, and this is the structure here for Y, and Momin is going to explain to us what type of hybridization we have with Y.
So if we see this Y here, and we consider this OCH, and we look at it in a bigger form here, we can see it has 4 domains. So these are the lone pairs and oxygen. This is the hydrogen, and this is the carbon. So as you can see, for explanation I've drawn the lone pairs. So there are 4 domains here, and hence it is sp3 hybridization.
Now we're ready for Z, and Vyom is going to explain to us what type of hybridization we have here in Z.
Over here you can see C, the carbon atom, is connected to the nitrogen, has a bond with and 3 other hydrogens. So that means there's a total of 4 bonds. That is 4 domains. This can only be explained via sp3 hybridization. So, as put by Momin, Kewal, and myself, the first one was sp2, the second one was sp3, and the last one was sp3 as well, giving us the answer of A.
So now we have another question. Which molecules here have sp2 hybridization? And Debaria is going to explain to us exactly how to arrive at the answer to this.
For this question, we of course need to draw out the structural formulas. So I'm just going to start with C2H4, a double bond here, and therefore the 4 hydrogens. And this is the first structure. I'm just going to continue with these structures. We now have C4H10, and I'm just going to not draw the hydrogens here, but we are supposed to in the actual papers. As for number 3, we can see it is the benzene ring. Now benzene is drawn like this. However, just for this demonstration, I'm just going to draw it in a structure with single and double bonds. So if we were to have a double bond here, a hydrogen here, we can use this in order to look at the hybridization. So here you want to check out the hybridization by looking at how many domains carbons have. Here we see we have 1, 2, and 3 domains. So 3 domains equals sp2 hybridization. Then we see this here, 1, 2, 3, 4 carbon, and since there are 4, this is an sp3 hybridization. As a benzene here, you can see that there's 1, 2, and 3 domains, making this sp2 hybridization. Therefore, looking at it, we can see that 1 and 3 are the only ones that have sp2 hybridization, which would make B the answer.